just a bit well known. So welcome and warm welcome to Sebastián.
Nice. Awesome. So, yeah, perfect, perfect. So good to see you all here. It's very exciting. Thank you very much for having me. We're going to talk a little bit about modern Python through FastAPI and friends. So first, who am I? I'm Sebastián Ramírez, or Tiangolo. I am from Colombia in South America. That's why the accent. But I live in Berlin, Germany. You can find me on GitHub, Twitter, LinkedIn, all that stuff. I created FastAPI, Typer, SQLModel, Asyncer, and like some other tools, some other small tools around there. That's why I'm here. Mainly, well, if you have heard any of this, it's probably FastAPI, which is a web API framework that has a bunch of GitHub stars and is used by a bunch of companies and like has like decent performance, and it's a few people have liked it. So yeah, that's like pretty much what FastAPI is. That's why I'm here. But we are going to talk about a bunch of other things. So we're going to talk about modern Python and like currently supported versions. I'm saying 3.7, but this is actually already end of life. So 3.9, you know, like if you're just using Python, is modern Python, then this is what we are going to talk about. We're going to talk a little bit about f-strings, a lot about type annotations, then a bit about async and await, then some about performance and community. All this through FastAPI and friends. So FastAPI, Pydantic, HTTPX, Starlet, Ubicorn, you know, like all these tools and how they are like working with all the other tools in the ecosystem. So we're going to start with f-strings that I hope is pretty much boring for most of you. If you are not using f-strings, then please do. So let's start with this. We have some data here. This is just a dictionary that has some recipes, and each recipe has some ingredients. And then we have some code here that is going to process those recipes to give us some particular recipe for some meal. Now, here's the thing. If we have a string like this, and then we are using dot format, then we are duplicating the information that this should have this name here in 3 places. So we have name here, then we have name here, and then we have name here. So it's a lot of information duplication that is just showing the same thing. When we call it, we just call get one recipe, then we get the data. Cool. If we say that, hey, we want to have the quantity is 2, then we are going to have a total of 2. So this is just like how you will call that function. Now, as I was showing you, we are repeating this information 3 times here. And we can just replace that by putting an F at the beginning, and then the same curly braces will just work. And these curly braces, this will take the variable that is whatever in the context of this. So this variable is going to come from this parameter name, and then it's just going to be inserted in this string. It's, you know, much cleaner, much simpler. You get like all the inline errors, auto-completion, all that stuff. It's going to be like a lot simpler. In this format, you don't necessarily have like all the tools don't necessarily can tell you, hey, you are passing here a keyword parameter that doesn't really exist in the string or things like that. This is just so much simpler because it's, you know, a single place where you are putting that. It also has better performance and stuff like that, but like the thing is, it's just simpler. So just use that if you are not using it already. And of course, when you call it, it just works the same as before. So you don't have to put a bunch of weird stuff. You can put simple stuff in there, and it's just cooler. That's it about f-strings. I hope that was boring and that you are already using f-strings for a long while. Now let's talk about type annotations. This is probably a bit more interesting. So we now have this code. This is the same code that we had before. But if we ask the editor, your IDE, whatever tool you're using, to give you auto-completion for this name, because we want to have the name in that title case. So we want the first letter of the recipe to start in an uppercase letter. And then we want to capitalize this thing. The editor doesn't know what this is. So the editor cannot give us auto-completion to show us like what are the methods that you can do. Is it like title? Is it capitals? Is it like what is the method that you will use in Python? If you remember, that's awesome. I don't have good memory. I need auto-completion, so I need the editor to do half of the job for me. So I need auto-completion. But you know, like we have been totally fine without auto-completion and type checks forever, so who needs types? But the thing is, we just have to put types in a single place. We don't have to put types for every one of the variables, just in the signature of the function. We just say, hey, this name is going to be of type string. And now suddenly the editor can give us auto-completion, and then we can say, ah, yeah, it's capitalized. That is the name of the method that we are looking for. Or if we want to, for example, like, I don't know, replace some internals, we don't want to have hyphens, we want to separate that with spaces, something like that, just in this simple example. The thing is we get auto-completion in the editor for that. And now we can just like let's replace the hyphen with a space. And the thing is, because the editor knows that this is a string, it knows that whatever method we call on this is also going to return a string. So the editor still knows that this is a string and can still give us auto-completion for strings. So we can replace it, and then we can make it in title case. Just like, in one go, the editor can help us a lot. Make sure that, on one hand, remind us what is the method that we can use, and on the other hand, make sure that the code is correct. And we can auto-completion and type checks in all the code. That's all we have to do to get that. And we can be happy like swimming Batman. Now, and well, this is the final code, how it will look like. Then now we can just like use this title inside of here instead of the previous version that we had before. And whenever we call it, now we're going to have, this is the recipe for Crunchy Frog instead of having like the old version that we had before. Pretty much the same thing, but it's like, you just get like some benefits in the editor. Now, let's say that we want to do a simple refactor. We don't want always to get one of these recipes. We don't necessarily want to order the food. Maybe we just need the recipe itself without asking for one of these plates. So it's quite simple. We just change quantity from 1 to none. And it sounds like, OK, yeah, that's pretty simple. We can just leave it like that. And it looks fine here in the editor. But then when we run it, until the time when we run the code, then we get one of these nasty tracebacks these errors that usually, oh, no, something exploded. I don't know what to do. Let's close the computer. And then you have to read, or unless like you're like a Python wizard that knows how to read these things that start saying traceback, most recent call, that's like, what is this saying? What is this source saying? But then like you end up just like going through the error and saying like, OK, this is my file, and then at this line, this is having an error inside of this function. There is another error here. What is this? This is line 23. OK, in line 23, what is the problem here? That this is an unsupported operand type, so I cannot multiply int and none. So you have to do all this work manually, checking the error that you have in the terminal or in your logs in your server if you already deployed it to production and you have just like, a call from a client saying like, hey, your server is down and it's 3 a.m. in the morning and you just have to wake up to fix the server. That's not great. This is just happening until it's running at runtime. But now, if we just add a type annotation here, we say, hey, this quantity is an integer. By default, it's none. The editor knows that because this is by default none, it also can be none, an integer or none. But just by telling it what I expect here is an integer, now the editor can give us some help. So now we can see that here, let me go back for a second. We can see that here we have the red squiggly line saying like, hey, there's a problem here, right in the editor, before running anything. And if we hover over that line, we're going to have a tooltip telling us, hey, this is the problem that you have here. You cannot sum an int and none. And this quantity is possibly none, so there's an error here. We get this error before we run the code, maybe before we commit the code. So we can say that we never actually made a mistake if we can fix it before. So we have the type hints are actually protecting us from a whole class of bugs that could like happen in production when everything is deployed and clients are getting angry and like you are sleeping at 3 a.m. Instead of that, you can get those errors early when you are still like, in working hours and you're still not sleeping, which is great. Because sleeping is great. It's good for development, if you didn't know. Like, coffee is great, but sleeping also helps. Now, we still have an error here. We have this little error, so we fixed this one. And the way that we fix it is that we are creating this data structure here, and then here we're checking, hey, if quantity is not none, and if it's not none, it means that it can only be an integer, then we can do stuff here. But still, it detects something, and it's telling us, hey, there's still a problem. And we can go and say, well, this is the fix, but then we can go and check, like, what is the problem here? What is it saying? And it's saying, like, hey, you are putting something that is an integer in a dictionary that I expect will have only strings or sequences of strings or something like that. So in this case, the editor is being super smart and trying to be too helpful and thinking like, oh, this dictionary only has strings and things like that. And we want to say, hey, like, don't care so much, you know, like, I don't really care if this has an integer, like, it's just an integer, just let me put whatever. I know what I'm doing. Thank you, I want you to know that this is a dictionary, but I don't want you to be so strict about it. So then we can just like tell it, hey, this variable here, this is just a dictionary. I won't tell you what are the keys or what are the values, just like take whatever I put. This is just a dictionary and don't bother with it. And now we don't have the error here. So we can have like very strict checks that can tell us like, hey, you have these errors here. But then when we want to opt out of those checks, we can also do that with the same type annotations, being more explicit that we don't want to be that explicit with the information that we have there. And now, the editor is smart enough to know that this quantity, we say that this is an integer, but the editor knows that it has a default value of none. So the editor can infer the information that this is actually an integer or none. We can actually put this same syntax in here, and it will be much better. But like, you know, if you are super lazy and just want to start using a tiny bit of type hints, you can just do this. And the thing is, the editor is smart enough that even though we say, hey, this quantity is an integer or it could be none, the editor knows that if we are inside of a block that checks if quantity is not none, inside of this block, quantity can only be an integer. So that's why we are not getting the error here inside of this block. So it's not just that we get auto-completion and inline errors. The editor also knows as the variables change inside of the code, if we give it like proper type annotations, like these things that we have in the parameters in the function signature, then the editor knows and can do a lot of smart things to know what are the actual types of the variables that we are dealing with. So we have like all the nice errors, but we don't get a bunch of false positives. And now, if we want to be a little bit more strict, and if you are in Python, you know, below 3.10, then you can import from typing import optional, and then run this integer in optional. This optional actually means this is non-able, so it could be an integer or it could be none. It's pretty much the same. If you are in Python 3.10 or above, you can just say integer vertical bar none, and the vertical bar is like a union between these two types, which is just like simpler. So you can just like use that simpler syntax without having to import anything. But this is the thing that is compatible with all the current Python versions available. And now we can be like super happy and strong like this doggy that we not necessarily were before when we were dealing with like all these possible errors that had to be shown at runtime. Now we can fix those errors when we are writing the code before we commit the code. So we actually never committed the error, and then we can go out and claim that we are, you know, like a 10x engineer or like expert in something, or, you know, put in the badge, I'm an expert in. Anyway. Some of the people that are behind these tools. So this guy started the language and the tool MyPy that has the type annotations to check that the code is correct. That's how this all started before it was part of Python. These guys are some of the people that are the core maintainers of these tools. And you know, like, it's just like normal people. That's just what I wanted to show. It's just like normal people are around just like working and helping others with stuff. Now, let's see a little bit of the modern Python with type annotations using FastAPI. So we're going to have this same data, this same function, but now we're going to import from FastAPI, we import the FastAPI class. Then we create an instance of this class, an app, and then we decorate this function with app.get. So what we are doing here, this @ symbol, if you have not seen it before, this means, hey, FastAPI, do whatever is your thing with this configuration using the thing that is below with this function. And what FastAPI is going to do is that whenever we receive a request that goes to /recipes/ this thing name, I'm going to explain in a bit, and it's an HTTP GET request, I want you to use this function to handle that request. That is what we are telling FastAPI here. And then this name is inside of these curly braces, which is the same syntax as the F string, so it should be relatively easy to remember, but this doesn't have the F here. What FastAPI is going to do is that it's going to extract from the path in the URL, it's going to extract this as a parameter, which is a name, and it's going to put it inside of the function in the parameter with the same name, which is this name that is a string. We have, like, you know, the same parameters. And now, that means that the more FastAPI code you write, the less API code you write. Because, you know, like, we added just 3 lines of code, and suddenly we have a full-grown like API for the same code that we had before. So you can focus on the business logic of your application, on the important stuff, instead of like dealing, with a bunch of stuff about building APIs and web development. Now, of course, because this is all based on the standard Python type hints and type annotations, we get auto-completion everywhere, and we can be happy like this cat. And we also get error detection and like the inline errors and all the stuff, the same as that we had before, because again, this is just standard Python type annotations. You don't even have to import some FastAPI string class or something. It's just like, standard string. That's it. And now if you start that server with FastAPI and you go to /docs, then you're going to have this automatic API documentation user interface that is generated for you based on your own code. And this is all because it's based on open standards like OpenAPI and a bunch of other things. So this is provided by another open source tool that does like the UI for you, but it's just done automatically. And you can interact with your API from the browser live, getting like all the information from the code that you wrote. So we know that name is a string, that is a parameter that comes from the path. This is required because it's part of the path. And we also have quantity, which is an integer, because we defined that it will be an integer. It has a default value, which means that this is not required. And this goes from the query parameters. So we just get like FastAPI is going to extract that information from those places automatically and then provide it to your code inside of your code, making sure that what you get in your code is the types that you define they will be. And if we execute that request, then this is gonna, you can see an example with Carl. Look, this is so cool. We just had a talk with Carl. It's amazing. I was at lunch, I was like, can I have like the fanboy moment and take the picture? Ah! So we get like, this is interacting live with the application while we are developing it. And we can just like work with the API directly, getting like all the information. So this is executing and sending us the message back from the API. This is all in the browser. This is just like happening in the browser. And we don't have to do anything additionally from writing code with type annotations to get like this generated automatically. So we can just like write some basic code and then Google FastAPI makes a docs user interface for you, which means you no longer have to go and update that wiki or like that Google Doc that is shared between everyone that like no one updates, and then everyone complains like, hey, why is this not working? Oh, right, we didn't update that 3 years ago. So you just have like something that is automatic for you. Now, it's not just documentation, it also does automatic data validation. If you try to send something that is not really an integer, for example, the text 9, then the user interface is going to complain already, because the user interface in the front end already knows that, hey, this is not really an integer, you need to pass an integer. But let's say that we want to cheat, and we want to use curl to cheat. So we are sending now, this is the URL, /recipes/crunchyfrog. This is the recipe that we want, and then this is the query parameter that we are sending. The query parameters are the ones that go after the question mark. So question mark, then a key or like a name, equals, and then a value. So we are saying, hey, quantity is going to be equal to 9. And the response that we get automatically from FastAPI is this thing that we have here that we can print it pretty here below, is the same thing. It's telling us, hey, you have an error in your request. So FastAPI is doing automatic data validation for us. And it's not only telling us, hey, your data is incorrect, it's telling us exactly how and where is incorrect the data. So we can see that in the query parameters inside of the quantity, the value is not a valid integer. So we can know exactly what is the problem, what is this data that I'm sending wrong, or the client is sending wrong, so they can fix it and send the data correctly. This means that we don't have to write like 50 lines of code at the beginning of the function just to validate that the parameters are the right types, and like with a very error-prone process, because FastAPI is just going to do all that for us just based on the type annotations. So without valid data, then FastAPI is going to protect us, and it's going to protect our code from running with invalid data that will explode the server. But with valid data, everything is just going to work out as the editor is telling you, with all the auto-completion, all the inline errors, then everything is just gonna work. And then if we send the request, so this will be the URL, crunchyfrog, query parameter quantity is gonna be 2, then we execute that, and now we get the response with the total 2, so we get the same stuff that we were having before, running the code directly, but now we have an API for that. And this is all based on standard Python type hints. Oh, the other thing, let me go back for a second. So when I'm back again, when we send this URL, when we use this URL A URL is a long text, it's a long string. A URL doesn't have types, everything is just text. But because we told FastAPI, hey, this quantity should be an integer, then FastAPI is going to extract this value from here, and it's going to convert it to an integer. So it's going to validate that it's convertible, but it's also going to convert it, because there's no way to send an integer in a URL if you know, it's just a string. It has to be converted. So it's also doing data serialization, data documentation, and data validation automatically, just based, again, on standard Python type hints and type annotations. FastAPI is based on standards like OpenAPI. OpenAPI uses JSON schema. It also uses OAuth2 and OpenID Connect and a bunch of other things. The thing, you don't have to learn those. You don't have to know all about those things. The thing is, you get automatic API docs. That's the cool stuff. You can also get automatically generated clients, for example, for the front end or for mobile applications or whatever you are doing, that are just like safe, type safe or whatever. You know, like the clients communicating with your API can have auto completion in linears, all that stuff. And this is all just based on standard type annotations. So you get all the benefits from using type annotations in Python that you should use, even if you're not using FastAPI, because you're going to get inline errors and auto completion, but you also get automatic data conversion, data validation, and documentation. Now let's switch. We are going to talk about building command line applications with Typer. So we're going to change all the code, and we're going to import Typer. We have the same data structure. We have the same function. We create a Typer app. This is not a FastAPI app. This is a Typer app. And now we don't say app.get. We say app.command in the decorator. And now we can say here, because we are not returning something to the command line, we have to print it. Then we can say typer.echo. Or you can just like say print. It will work pretty much the same. And then we can just print the result. And now we suddenly have like some Typer salt in our code, another 3-4 lines of code, and now we have a command line application for the thing that we are building. We can run this program Python main.py. Let's say that our code is living in this file main.py, and then we get automatic help and automatic validation. It's telling us, hey, main.py needs to have a name argument that you are not providing. So you can try to get the automatic help because there's a missing argument name here. Now, if we pass the argument, hey, main.py crunchyfrog, this is the name that I want, then we get the stuff that we were printing, we get it printed back again. And if we want to pass the optional parameters, these are converted to automatic command line options like this one. So dash quantity, this is not required, it's optional, but then we can pass a value here. So quantity is 2, and now we get the total 2. So we get automatic data processing for the command line, again, based on the same Python type annotations and based on the arguments and the parameters that we defined in the functions. And if we pass invalid data, we say like quantity is going to be 9, which is a string. Again, we get automatic data validation. So we're going to say, hey, there's an invalid value for quantity. 9 as a text is not a valid integer. So again, we get automatic documentation, validation, and serialization for the data, just based on the type annotations. I mean, with Typer, is doing all that from the standard type annotations. And with Typer, if you build an application with Typer, and like someone installs it with pip install super awesome app or something like that, or an application that is called like Typer as well, for example, then you're going to have you can install and use automatic shell completion that is going to work for all the shells, including Bash, C shell, PowerShell, and Fish. I said PowerShell. It has auto completion for PowerShell. It's so difficult to get that working. You know, like in Windows, getting that to work, but it works. And you don't have to do anything for it to work. Then your program is going to have an automatic option that is going to be install completion, and then your users are going to be able to say tab, 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 and it's just going to auto-complete everything. So we can say like, hey, main.py, well, in this case, is this Typer application, which is another application that I built that will allow you to run scripts directly that you build with Typer without having to create a new package. And then you can say run -q, and it's gonna, you hit tab, and it's gonna autocomplete what is the name of the parameter or things like that. And now you're building command line applications with Typer, so you can feel like a hacker man. Now, let's add to Typer, let's add a bit of Rich, which is another library that provides great tools for displaying information on the terminal. What we are going to do is that we are going to import from Rich, we're going to import a table, and we're going to import a console. Then we're going to create an instance of this thing called console. Then we're going to create an instance of this table that is going to have a title ingredients. Well, this table ingredients that is going to have this table inside. And then for each one of the ingredients that we were going to print, we were going to add them to the table as rows. And then we console print that thing. And if we have a quantity, we also console print the total. So, you know, like pretty simple Python, just using rich. And now suddenly we have a very nice looking user interface for the command line application that we are building. And you can build, you know, like great command line applications with Typer and Rich. That's the idea. Some of the people behind these tools. So Typer is built on top of Click. And Click is the current maintainer of Click is David Lord. That is also the current maintainer of Flask and a bunch of other tools. And, you know, like it's a lot of work for a single guy that is not necessary. You don't necessarily go and like see him everywhere, but he's just doing a lot of work. All the stuff in Typer behind the scenes is being done by Click. And Will is the creator of Rich, which is the other tool that we were using. So again, you know, just like pretty simple people, normal people like us. For real. Well, I mean, they sleep less and they don't have weekends. But apart from that, now let's add a little bit more. So FastAPI is being built on top of two libraries. One is called Starlet. It does all the web parts. You normally don't interact with it directly that much because FastAPI does everything on top of that. But Starlet is the one that does all the web stuff. And the other one is Pydantic. Pydantic does all the data parts, all the data serialization, data documentation, and data validation. So we're going to use Pydantic now. We're going to have, this is a simple application for food stuff. And now we're going to import from Pydantic, we're going to import a base model. And then we create a class food that is going to inherit from this base model. Then we use the standard Python type annotations to define, hey, this data. So what we are going to do is that we are going to receive data in the API as a JSON payload. So we say, hey, this has a name that is of type string. This doesn't have a default value, so this is going to be required. And ingredients is going to be a list of strings. That by default is just an empty list. This has a default, so this is not required. Now, this list with the square brackets, this is standard Python type annotations. We import this list from typing. Typing comes with Python. If you are in Python 3.9 or above, you can use just the standard list without having to import this. But you still use the square brackets. So again, this is just the standard syntax that you will use to say the type of ingredients is going to be a list of strings. And now we just put this class food, we put it inside of the function. Now this function is going to be an app.post. So whenever someone sends an HTTP post request, so sending data to the API. And now we say this function is going to have a parameter called food that is an instance of the class food. This is, again, standard Python type hints. This is the way that you say that this parameter food is going to be an instance of the class food. It's not the class itself. It's an instance of the class. And this is like the standard way to declare that. And now FastAPI will make sure that this is what we receive inside the code. So you can do food.name and get the name of the thing that you received, or food.ingredients to get all the ingredients. And if we go to the automatic API docs, now we can see that this is a post request that goes to /food and that receives this type of data. So we have an automatic example showing us what is the shape of the data that we will receive. So name is going to be a string, and ingredients is going to be a list. Or in JSON terms, this is going to be a JSON object, and ingredients is going to be a JSON array. But you know, it's just like the same thing. The cool thing is, this is automatic data documentation for the data shapes that you care about in your application. It's not for the whatever are the things that come with FastAPI. It's for your application. The shapes, the names, the keys, whatever you want to define, that is what you get in the documentation. And if we execute it, then we can just like send a request, and then we're going to get something. So if we want to send an albatross, which has as ingredients an albatross, then we can just execute that, and we're going to get the response back. Now, we also get data validation automatically. If we say, hey, I want to send an albatross, and the ingredients is an albatross, and inside it has another JSON object, or like a Python dictionary that has some key name and like some value frogs. This is not a string. We say that we wanted to receive ingredients will be a list of strings, but then this second item here is not really a string. If we try to execute that, then FastAPI is going to validate the data, and it's going to give us a response, an error response telling the client, hey, you are messing up your data. You are sending something correct. But it's not only saying, hey, there is a bad request. It's also telling us exactly where is the problem. Inside of the body, inside of ingredients, at index 1, so the second item, a string type was expected, and this is not what was sent. So we get automatic data validation for the data shapes that we care about. And we don't have to, like write a bunch of code checking like, oh, is this a dictionary? Is the dictionary of strings? Is each one of is this particular key a list? Is this key full of strings or not? For each one of those, check if it's a string. There's 50 lines of code just checking if the data is correct. We just define that with type annotations. FastAPI does all the validation for us using Pydantic. Pydantic is the thing that is doing all the data validation behind the scenes for FastAPI. Now, if we want to say like, okay, but I don't want to receive a single order, a single item, I want to receive multiple, then again, we just use the standard type annotations. Now, we're going to receive orders. It's going to be a list of instances of the class food. And FastAPI will make sure this is what we receive. So now we can iterate for each one of the food items in orders, and we can do stuff with that. So if we want to put JSON and we want to put it inside of JSON, then we can just like do it. We can use arbitrarily complex nested data structures, like, however weird stuff you want to write your application with, however you want to write your JSON, you can define it with standard type annotations, and FastAPI is going to do the data validation, documentation, and serialization for you automatically. Of course, because this is, again, based on standard type annotations, we get autocompletion for each one of the things. So the editor will know that ingredient is a string, and look like we are in a double nested for loop, and instead we get autocompletion and like all the stuff. This is because the editor knows that ingredient is a string because ingredient comes from food.ingredients. And it knows that food.ingredients is a list of strings because each one of these food items comes from the orders. And it knows that the orders is a list of food instances. So we define the type annotations just at the beginning of the inputs of the data, and then the editor does the rest down the line. We just get autocompletion everywhere. We don't have to put type annotations in all the places. We shouldn't do that. We just put the type annotations in the right places, and then we get like all the benefits down the line. And you can have autocompletion everywhere and be happy like this guy that doesn't have to remember stuff like me. Now, we also get automatic error detection and inline errors in the editor. If you try to sum an ingredient, which is a string, with a number, then you're going to get an error telling you, hey, the string cannot be summed with an integer. You have to do something about this. So this is another case where you didn't commit the code that was erroneous and that will end up breaking the servers at 3 a.m. and they will have woken up everyone to fix something that could have been prevented by these type annotations. Some of the people behind these tools. So Samuel Colvin is the creator of Pydantic. Tom Christie is the creator of Starlet, and a bunch of other things. He's also the creator of Django REST framework. You might have heard of that. Tom Christie created Django REST framework, then created another tool that was the main inspiration for FastAPI. Then he had to stop with that tool, and then created Starlet, which is the backbone or FastAPI for all the web stuff. David Montague is a Pydantic and FastAPI notorious contributor. He helped a lot with those projects, and like from the early beginning, he's super cool and like helped a lot of people. Now he's working in the same Pydantic company, and they are doing like a bunch of very cool stuff. I just wanted to show you again, normal people, like a bunch of nerds doing cool stuff, trying to solve problems, and like that's pretty much it. Now, we're going to talk a little bit about FastAPI with the SQLModel. So SQLModel is this other library that I built, again, using these type annotations and this stuff to handle and to work with databases. So the way that you will do is pretty much the same that you will do with Pydantic. We create a class. In this case, it's a class here that inherits from this class SQLModel, and we're telling it, hey, this is going to be a table. I want this class to be a table. Because we can define classes that are not tables and are just like pretty much Pydantic models for data validation. But then we can say, hey, this particular one is going to be a table. Because we define which ones are going to be a table in the database, then we can use inheritance and stuff to avoid duplicating a lot of the information, but still being able to have a single model. In this case, this class itself is a Pydantic model and a SQL Alchemy model. with respect to Pydantic, this is a Pydantic class. With respect to SQLAlchemy, this is a SQLAlchemy class. SQLAlchemy is the tool that does all the SQL stuff behind the scenes. It's like the most popular tool for interacting with SQL databases, apart from Django ORM. But for Django ORM, you need Django. So for all the other cases, you will use SQLAlchemy. Or, well, SQLModel that is built on top of that. Now, again, we just say like, hey, ID is going to be an optional integer, again, standard type annotations. And this is going to be, in the equal side, we just use this special function. This is inspired by the same ideas from data classes. So we're going to have a field. By default, this is going to be none. And we have this default none because we want the database to create the primary key for us. And we are saying, hey, this is a primary key. That's it. Then we say, hey, name is a string. This means that whenever we are validating data, for example, in a request, this is going to check that name is actually going to be a string. But this is also going to tell the database, hey, the column name is going to have strings. And secret name is going to have also strings. And then age is going to be an optional integer. So an integer that could be none. And by default is none. By having a default of none, then this is not going to be required when we use it for a request or something like that. It also means that whenever we get the data, it's going to have a default of none. But it also tells the database, hey, this is going to have a default value of none. And this is a nullable column, a nullable column. So we are defining all that information. We don't have to duplicate in one model for data validation and another for databases. We just can put all the information that is actually related and saying the same thing for different aspects, but it's the same information in a single place. Now we can create an engine with this. I'm not going to talk a lot about the details, but then we can create all these, all the tables that we defined in this SQLite database that we are using. And now here's the trick. Here's the cool thing. So we can use the same class here in the parameters for FastAPI to say, hey, FastAPI, I want you to validate the data using this class here. Then we can use the same object, and we can use that object to put it in the database directly. We don't have to convert it to another model or something because this object is already a SQLAlchemy model. So then we can save it to the database, then we can commit the session in the database, we can refresh the data to make sure that we have something recent for this object here, and then we can return the same object that comes from the database. And because this object is also a Pydantic model, then we can just use it directly. We can use it in the response model parameter, or we could have put the return type annotation here to say we are returning a hero. And then this means that the data is going to be validated when it's going out for the client. So we can make sure that whatever we say that we were going to send to the client is the thing that we are actually sending it. And if we had additional data, additional stuff, this response model will also be used for filtering data, to make sure that we are only sending what we say that we are going to send and nothing else. And of course, we get automatic data validation, serialization, and documentation in the web UI. If we want to return lists of these objects, then we can, again, just use standard type annotations. And then we can say okay, I'm going to use this session. With the session, I'm going to execute a select query to get all the hero rows from the hero table in the database and just return that object directly. So now we have, so this is I don't know, 4 or 5 lines of code that we can use to have an API to return all the heroes from the database with automatic data validation, serialization, documentation, all that stuff. When we go to documentation, we can see that we have get heroes and we have post heroes. Because this is a Pydantic model, we get all the data documentation for the data that we expect to receive. And we also get the definitions of the data that we expect to return. So we can have database and data models in the same class without having a bunch of duplication and errors of synchronization of I have this information here, but I forgot to update it here, and then I have to keep everything in sync by hand. Some of the people behind these things. So Samuel Colvin, again, the creator of Pydantic, and Mike Bayer, the creator of SQLAlchemy, which is this thing that is just doing all the work of the SQL side behind the scenes. Again, normal people with cats in the background and stuff. Now let's switch gears. We're going to talk about modern Python with async and await. So first, what is the deal with that? So when you have, let's say that you have a Python backend and you have some client, and the client sends requests and the requests come back. Python is a very fast programming language when you compare it to the network. So the thing is, the client is going to send a request. This is going to go very slowly. While this is going very slowly through the cables throughout the world, Python here is just waiting, doing nothing. Just like, you know, like the CPU is sleeping. Then the request comes here, then Python starts just like using the CPU and doing stuff, very fancy stuff, and like doing all the AIs and everything. And then it returns the response. And then the response goes back very slowly through the network back to the client. While it's going very slowly, Python here is again just like sleeping. The CPU is doing nothing, just waiting for that to finish going. So then the request goes slowly back to the client. This is what is happening. Now, then we could say like, okay, then we probably can have like the same Python backend, the same Python code, serve multiple clients at the same time. That way, we can like, you know, take advantage of like the CPU instead of having it sleeping, just like working and doing stuff. And this is a great idea. The problem is that in reality, it's a bit more like having a line waiting for the cashier. And then like, you know, this guy really wants to buy like, I don't know, some groceries, and then he has to wait for someone that is buying toilet paper and someone that is buying alcohol or something to get through the cashier, pass items slowly in the band, find cash and coins and like count and stuff, while this guy is waiting, this other one is waiting, the cashier is also waiting, everyone is just waiting in line while a single transaction is done. So it's a lot of waiting, a lot of people and things waiting for one single thing to happen. So it's a bit more like this. You have one client that is sending a slow request and then a slow response coming back. And then you have another client that will have their own turn to do that. So even if you have many clients, you don't necessarily have like all that stuff happening during the same period of time so that you don't have to wait for each one of those. Now, you will have your API just like waiting for the network and not like doing much. And it will be very sad for the CPU that is getting cold just sleeping. CPUs like to be hot and crunching numbers and stuff. Now, the idea is maybe we could have a waiter that will go, let's say that each one of the clients is just like sitting at a table, and then the waiter will go to each one of the tables, give them the menu, and instead of waiting for each one of the tables, hey, what do you want? They're just gonna check the menu, take your time, and then go to the next table. So the waiter is not waiting for each one of the people that is just sitting at the restaurant. The waiter is just like giving them all the menus. And then the waiter can come back to the first table, and they probably already know what they are gonna ask, and then they can take the order, and then go to the next table, and the next table is my sister. My sister still doesn't know if she wants chicken or not, so he can go to the next table instead of waiting there for like, okay, just take your time and decide. No, he can just like go to the next table and ask for the next people at the table, get their orders, then go back to the kitchen. So it's something like this. We have in Python, with async and await, Python is giving us some type of waiter that is running inside of the same Python. It's just that we don't have to make it work. It just works behind the scenes. We just tell it to do stuff with async and await. But then this is the thing that is going to be waiting in each one of the tables, going, giving them the menu. And then while this is going back through the network, this same waiter and the same stuff is going to be able to communicate with the next client. So that instead of having everyone waiting for one single thing to happen, we can wait for many things to happen at the same time. And this is what they call with concurrency. Concurrency doesn't mean that things happen exactly at the same time. It's that things happen during the same period of time. So normally it's like one little bit of one thing happening, then another little bit of another thing happening, then another little bit of the first thing, then another third. And you know, like it's just jumping back and forth. It's probably one single piece of code that is being executed every instant in time, but they are all being executed during the same period of time. This is all the stuff with concurrency and throughput and performance in those terms. And this is how you will use it in code. So FastAPI underneath is an async framework. So you can write a function with async, and then when you write something with async, you can use async stuff inside. So we can import HTTPX, and we can say, hey, I want to use an async client. And then with this client, by using an async client, now we can use await inside of it. And this await is where we tell the waiter, hey, This is probably going to take a while. So go and do some other stuff that might be happening during this time. You probably have something else somewhere, probably handling another request or something. Go and do that while this is done. For this to be called, this needs to be compatible with async and await. So you cannot just like put await randomly inside of the code. It needs to be some, you can put await only in things that were declared with async. So you need to make sure that all the libraries are compatible and like all the stuff to be able to use async and await properly. But you actually don't have to do that. You can, well, and if you go to the documentation automatically, you get like all the same stuff that we were talking before, and you get the responses. So this all works as normally. You don't have to use async and await. You can with FastAPI. You can use regular def functions, and then you can use HTTPX directly without using async as well. So there are some libraries like FastAPI and HTTPX that are both compatible with async and non-async code. And the thing is, you can use this to be able just to start writing the code, probably migrate whatever is the application that you have that might not be compatible with async and await, and this is going to do the smart thing to make sure that your code is running as best as it can without using async and await. If you like the details, this is going to run each one of these functions in a thread worker, in a thread pool, so that it doesn't block the event loop in the main thread. If you don't understand that, don't worry, I don't understand it fully either. But the thing is that it's going to do the right thing. So you're going to be able to just like have the best that you can without having to hyper optimize and like spend 2 weeks just writing one single function to make sure that everything is working correctly. And the thing is like, you know, like you can just like use async and await for the things that require like squeezing all the performance. And if not, you can just like use this, and this is going to still give you the best that you can get in that scenario. So you can use normal def and you can use async def in the same code. Even in the same code base, in the same app, you can have some functions that are async and some that are regular def, and everything is still gonna work. Some of the people behind these tools. So Tom Christie, again, the creator of Django REST framework, Starlet, and HTTPX, and also Ubicorn, which is the server, and also MakeDocs, and like a bunch of other things. He's just like super prolific. Marcelo Trilesinski, currently he's the co-maintainer of Starlet and Ubicorn. Starlet and Ubicorn were created by Tom Christie, but now Marcelo has been like the main maintainer for these libraries, and he has been helping a lot with FastAPI. He's currently the top FastAPI expert, which is the person that has helped the most other people with their questions. Andrew Godwin is the author of the ASCII specification. So all this async and await stuff with Python, this is actually a specification. This is a standard that goes underneath so that multiple things can be compatible between each other. And this is the author of that. This actually came from the Django world. All this, how are we going to do async web, came from the Django world, from this guy. And now, you know, later FastAPI ended up being like the biggest async thingy, but you know, it's still like all based on these ideas that a bunch of other people have been working on. Again, as I was telling you, it's just like, again, just normal people. Now a little bit about the performance with FastAPI. So this is a benchmark run by a third party called TechEmpower. They compare a bunch of different languages and a bunch of different frameworks and stuff. I'm showing you only 2 languages, Python and Go. Go lang is a compiled language, so it has to be faster than Python. It should, it has to. Nevertheless, FastAPI and a bunch of others here managed to be, you know, like, in the ballpark of stuff that could be comparable to some of the frameworks that are written in Go. So you can get like pretty decent performance while still being able to stay in the comfort and productivity of Python. And which one of these is the fastest is not necessarily super clear, because, for example, Ubicorn here is below all these others, and Ubicorn is not a framework, Ubicorn is the server. Ubicorn is what you will use to run everything on top. So Ubicorn will have to be above everything. So, you know, like it just has some random noise error, but the thing is, you get on the ballpark of the best that you can get in Python. And as you can see, in this case, in this particular benchmark, in this particular server or whatever, it's been able to handle 15,000 requests per second, which is over 9,000. So you can be happy about your application. Now, why is FastAPI fast? FastAPI doesn't really do much, like a lot of smart stuff underneath. It's just building on top of the shoulders of giants, of other giants. FastAPI is built on top of Starlet, which is the web or toolkit or micro framework that does all the web parts. Starlet uses the ASCII specification and is run by a server called Uvicorn. So the same way that in Django or in Flask, you will use something like Unicorn or UWSGI or something like that. That component is the server. The server is the thing that is listening on a socket and understanding HTTP and all that stuff. Then the framework on the other side, like Django, Flask, or FastAPI, is just going to handle a dictionary with the data, with a dictionary that has the URL, and that has the data in the body, and that has the parameters. But then FastAPI, Django, Flask, none of these guys is going to understand HTTP directly. It just reads a dictionary and handles that. That's why this is separated. But then Uvicorn internally uses UVLoop. UVLoop is a high-performance drop-in replacement for async I/O. You don't have to know that you have to use that. It's just used underneath. But the thing is that this gives you crazy performance because UVLoop is built with Python, which is a compiled version of Python that allows you to create C extensions for Python. And UVLoop using Python uses the same library called libUV that is the same thing that handles the same event loop in Node.js. So that's why you get the same concurrency, performance, throughput, whatever, that you will get in Node.js. And on the side of Pydantic, that does all the data validation, serialization, and documentation, it was also built with Python, but now it's rebuilt with Rust. The internals were rebuilt with Rust. So before it was super fast, now it's 20x times faster because the internals are built with Rust. But nor you nor I have to learn Rust. We can just stay in the comfort of Python and then use to our advantage all the work that these people are doing to give us like all these very high performance tools. This is like, like required slide after saying anything about Rust anywhere. In the case of FastAPI, it wouldn't make that much sense to write something in Rust because we are already taking advantage of the thing that needed to be written in Rust. Of course, there can be like done some profiling or stuff, but maybe it will make more sense to do some Rust in the Uvicorn side or like in other sides than in FastAPI directly. But yeah, maybe there are more things to be done. The thing is, FastAPI is built with high-performance projects. That's why FastAPI is fast. It's not that it's doing something super smart. It's just like taking advantage of all the work done by a lot of other people behind the scenes. That is just, just like building blocks that help us build stuff on top. So we can, again, stand in the shoulders of giants. Some of the people behind these tools: Tom Christie, creator of Starlet, also Uvicorn. Yuri Selivanov, he's the creator of UVLoop, which is this very high performance thing. He is also the guy that added async and await as keywords to Python. Stefan Benel is the maintainer of Python, which is this thing to compile C extensions to Python. And you notice this guy is one guy. He is the guy that maintains Python. Python is the thing that allows all the high performance stuff in Python to work. So NumPy, like TensorFlow, PyTorch, all that stuff is underneath using stuff with Python, maintained by one guy. And UVLoop, async and await, and all the stuff by another guy. All the stuff that we say is high performance in terms of concurrency and like stuff in Python, this is all just thanks to UVLoop. FastAPI nor any other tool is really doing something specifically about that. It's just like that UVLoop is running underneath. And again, just, one guy. So this is like probably the main point. This is all done by normal people like you and I. They probably have more coffee and sleep less and have less weekends. But still, it's just like people that roll up their sleeves and do that. It's mostly during the free time. Most of the open source projects are being handled during the free time of the developers. I am in a very privileged position that I can work full-time on open source, but most of the people are actually just like, doing it out of their love for the art and like the good stuff in their heart or something. It's like, I don't really know. Just like trying to help others. So, it's not like it's like an elite tribe or something like that. It's just like very normal people. And, it's just maintainers that could have had hobbies. Daniel could have been playing video games 20 years ago, but he has not been playing video games for 20 years just to build curl so that we can run helicopters in Mars. So, it's like just a bunch of people trying to help others. Now, you can help too. And there are very simple ways to help most of the projects that you are working on. In most of the cases, you can go to the project that you are using and check there's a section about help or contributing or how to help. And there are normally very easy ways to help. You can translate a page in the documentation. In the case of FastAPI, there are translations for a lot of languages. You can help translate a page, a single page. You can find a typo. Just like when you're reading the documentation for your favorite library, you're going to find a typo. Just go and create a pull request and fix the typo. That helps a lot. You can answer questions from others. This is super important, super helpful. It's the biggest time consumer for a developer, for a maintainer, and you can help a lot with that. Or you can help with bugs and features, and you can help with many of the other projects. Well, that's what I have for you. Thank you very much. Thank you.
Thank you so much. I
Do
think we still have time for a few questions, maybe like one or two.
Cool, awesome.
And
also, like I'm gonna be just like outside, hanging out in the hall. So if you wanna come and chat and like ask stuff, tell me stuff. I would love to know if you are using any of these tools. I would love to know how you're using it because I normally don't get to know how people are using it. So yeah.
Right. One question.
Hang out there.
Just a question regarding the, for example, let's say we have class A and class B, and class A references has a property of class B, and class B has a property of class A. And if we keep those classes in different files, we will get the circular dependency issues. How can we solve it? Because, for example, coming from C#, in C# we don't have this issue. It can reference the parent. But how about the Python?
Yeah, the thing is, for what will you need that? If it's for receiving data, then why would you have like references that could have like an infinite tree of stuff? It could just like, you will be creating a way to overload your server. So you will probably want to define what is the exact shape of data that you want to have. If you want to have both versions, some version that has like a reference to the other class and some other that is just for receiving the data, you can use inheritance to have one that has like the relationship with the other class and then one that doesn't. If it's for the database, then if you're using SQLModel, you can also use these cycles in references. They are not going to be included in the Pydantic models precisely for the same reason. And there's a couple of ways and a couple of tricks that you can use to be able to handle the references, but you can read the docs in the SQL model because explaining it like just like with my hands is going to be more difficult. But yeah, you can do that in those cases. The main thing to think about is why do you need that and what for?
Yeah, but sometimes, yeah, especially when we're refactoring old stuff, we encounter some things like that, and we have to reference the parents, but in order not to be forced to remake the code from scratch, because
yeah, it probably depends a lot on the use case. But if you want, we can also chat more outside. Like, what are the other ways to handle that, or what else to do? Thank you.
Thank you so much.
Thank you.
Thank you so
very
much.
Thank you.